Hi all. So today we'll be discussing an very important problem, that is rainwater trapped. So it's also a very common problem that is asked frequently in the interviews. So here you would be given an array or array list of non-negative integers representing an elevation map where the width of each bar is 1. So you have to compute how much water is trapped after raining. So you have the problem constraints and example inputs as given in the screen and also their outputs. So let's discuss like what is this problem and what is it's trying to ask us to do. So let me show you a first example. Suppose you have an input array list of 1, 2, 4, 3, 4. Okay. So this 1, 2, 4, 3, 4 represents the height of the buildings or walls. Okay, you have to consider that this problem, in this problem, the array list inputs are basically the heights of buildings or walls, and you have to assume that the buildings and walls they are connected with each other and there is no space in between them. Okay, no empty space in between them. They are connected with each other as you're seeing on the screen. Okay, so height of the first building is 1, so this is represent this is at array list index 0. So the next height is 2, so this is present in array list index 1. So the next array input is in the array list is the building height is 4, which is present at index 2. So the next building height is 3, it is present at index 3, and the next building height is 4, it is present at index 4. So you have to compute here how much water is trapped after it has rained. Okay, so consider it's raining, heavily raining. So the building present at 0, 1 and 2, they won't be able to trap any water, because if it rains, uh, the water will fall here, water will also fall here, but it will escape because there is nothing this side to contain the water. Okay, however, when the water falls above this 3, okay, so the water will get trapped because we have buildings of larger heights at both the ends of 3. So if it rains, suppose it's raining, water will get trapped here. Okay, it will not get trapped here, it will overflow here, overflow here, overflow here. It won't get trapped here also, it will overflow this way. So only position that the rainwater is going to get trapped is here. Okay, so how much rainwater is going to be trapped here? That is this area. Okay, this height, sorry, this height. That means 4, that means 4 minus 3, 1. So you need to return 1 or you need to print 1. So let me also show you a different example. Suppose this example. Here we have array list of different building heights 1, 2, 4, 3, 1. Here if you see, nowhere the water is going to get trapped, because if it rains, water will fall here, it will drop here, here, and it will escape. It will drop here, then here, and it will escape. So in this case the output will be 0 because nowhere the water is going to get trapped. Okay, so let's move to a third example just to be more clear on the problem. So here we have a input array list of 3, 2, 4, 3 and 4. This represent the heights of the buildings or walls. Suppose here it rains. There are two places where water is going to get trapped. One is here, okay, other one is here. So these two places, the water is going to get trapped. The remaining all places is going to overflow. Sorry, it's going to overflow and nothing will remain as the building height, as the building cannot contain any water. Okay, so the water trapped will be here at these two places. Okay, so this one site is 1 and this one site is also 1. So total trapped water will be 2. Okay, I hope you are getting what I'm trying to explain. So let's get to the code, like how to code this thing. The basic intuition behind explaining you this problem is like you might get a different kind of problem also, not similar to this. However, if you learn the approach which I'm trying to explain you in this video, by using that approach, you can develop your own intuition and give a solution to even a different problem. So what I'm discussing here, that's not the only answer. There may be different answers, but the reason behind explaining you this problem is to create intuition so that you may also come up with your own answer in case you are asked some different kind of problem. Okay, so let's get to the code. Okay, so let's see how to implement the code for the following problem. So here we have a get rainwater method that is going to return the total water trapped in the problem. So here you are going to write your code. So in the main method, I have already created an array list and I have passed all the values for this problem. It is 32434. Okay. So I'm simply calling the get rainwater trap method and it's returning the total water trapped and I'm simply printing that. Okay. In the interest of time, I have already written the piece of code and I'll simply explain you that code here. Okay, part by part. Okay. So the first thing which I am going to do is I am going to calculate the building index of the building. Okay, please note index of the building which has maximum height. Okay, so uh, in this case two buildings 4 and 4 both have the same height, so I'll be considering the building 4 here only, represented by this pivot. Okay, so you might have the question like why I'm not considering the other building which has the same height 4. That's because, as I explained it to you earlier, no water is going to get trapped in the first or the last building. Okay, the water that is going to be trapped is only going to be within the after the index 0 and uh, after the index 0 and prior to the index 4. Okay, so there is no use of considering the building with heights 3 and 4 that is present at the location index 0 and 4. Okay, so because of that I'm looping from index 1 and I uh, and I can loop till index size -1. Okay, here the a of size is 1 2 3 4 5. Okay, so it's going to loop till 4, so I have done it -1, so it's going to loop till 3. A of get I, so height will be the new maximum height, that is a of get I, and the max index will be the I. Okay, so here we'll be finding the index of the building which has the maximum height but considering we are not including the first and the very last building. Okay, so the approach which I'm going to follow here is like I'll be dividing this array into two parts. Uh, so there will be one part called the left end, which will hold the maximum water trapped from the left end to till the maximum height building, and there will be another part, that is the right max, which will be holding the maximum water from the right end till the building which has the maximum height. Okay, so the the way to calculate the maximum water trapped from the left end till the building with maximum height and the maximum water trapped from the right end till the building with maximum height is almost same. Okay, so let me just put the code which will calculate the maximum water trapped from the left end of the building. Okay, so here you go. This is the code for the maximum water trapped from the left end of the building. So here uh, I have taken an variable maxleft which holds the first element of the array list. Okay, note this is the first element of the array list. Okay, that is 3. Okay, and I am looping from the index 1 instead of 0 because as I said, there is no need to consider the building which is present for the first position because no water is ever going to get trapped here because nothing is present this way. It is going to be overflow always this way. Okay, so let's move to the code. I'm looping from the index 1 instead of 0 because of the reasons which I have mentioned, and I'm looping it to less than max index, that means less than 4, that is still here till index 1. If you take a larger array, then it will be fairly easier for you to understand, that you can do by your own. So here height, I'm assigning it to the uh, a dot get I, that is a dot 1, that is 2. Okay, here height is equal to 2. So the maximum max left I am calculating by the math function, that is I'm calculating the maximum of max left and height, that is uh, higher between 3 and 2. Okay, as per the graph, that is 3. Okay, so obviously the max left is greater than height. Okay, 3 is always greater than 2. So the water trapped is max left minus height, that is 3 minus 2, that is equal to 1. Okay, so we are placing this uh, water trap, that is 3 minus 2, that is 1. Okay, in this variable. Okay, similarly we will write the code for maxright. Okay, so here you go. This is the code for maxright. So the thing which you need to take care here is the range in which you are looping, otherwise you will get incorrect answer. Okay, because of the reasons which I have mentioned. Okay, so max right, I am taking it as this value 4. Okay, however I loop from 3 till the maximum building in the middle. Okay, so I'm looping from size minus 2 till max index from the right end. Okay, from the right end. Okay, so similarly here height is equal to a dot get I. Okay, so here the height is equal to 3. Okay, here the height is equal to 3. Okay, so maxright, so similar way it's calculating the maximum element between maxright and height, that is 3, sorry, that is 4 and 3. Greater between 4 and 3, so it is always 4. So as so this is going to calculate the water trapped from the right end. Okay, maximum water trapped from the right end. So similar way as I explained above, so this is going to be 4 minus 3, that is 1. Okay, so 4 minus 3, okay, that is 1. Okay, water trapped is equal to 1. Okay, so in the end, like what we're going to do is we're going to return the water trapped, which will hold the maximum water trapped from both the left and the right end. Okay, okay. So let us debug this code so that you can understand better. Okay. So let's debug this method. I have placed a breakpoint over the get rainwater trapped method, and let's see how this is executing. Okay. The step over, so the rainwater trapped value is 0. It's trying to get the height, so height is 3 and max index is 0. So now it enters the for loop where we are trying to determine the maximum height of the building uh, and its corresponding index, max index. So here it's getting into the loop and it's calculating the maximum height. Okay, so mm, so here it's able to get the maximum height as 4 and the corresponding index as 2. Okay, that means it's here now. Okay, so it's doing it one more time because we have the loop. Now it has exited the loop and it's trying to calculate the maximum water trapped from the left end of the buildings. Okay, so it has entered the for loop, and here it's trying to uh, calculate the maximum water uh, from the left end of the building. Okay, so you can read the values mentioned in the left end of the screen and try to understand it by itself. It's fairly easy. So it's entering the loop. As you saw, like it was able to calculate the maximum water trapped on the left end of the building, and now it's trying to enter the next part of the code, like it's trying to calculate the maximum water trapped from the right end of the building. Okay, so it has entered the if condition. So here the height is 3 and the max right value is 4. So we are here able to calculate the water trapped is equal to 1. Okay, now it has exited the for loop, and the total water trapped in this case is 2, and it's able to return that. Okay. I hope you like the explanation of this video. Uh, for the interest of time, it's difficult to get into each and every detail in the debugging process. So I had to quickly uh, step over the lines But in a similar way, you can do it by downloading the IntelliJ IDE. Okay, I hope you like this video, and I am sorry if I have missed any edge cases or if I have gone wrong in any part. So if and if you feel that some of the part is not correct, like, you can ping your opinions in the comment section. Okay, thanks for watching this video.